Hello community and hello future. I'm Matt Woodward, the Head of Developer Relations here at Swirlds Labs for Hedera, the most used leaderless proof-of-stake network. It's my pleasure to welcome you to the Hedera Ecosystem Week, where we're going to be sharing updates from in and around the community, including updates from our very own roadmap and associated Hedera Improvement Proposals, or HIPs, where you'll hear from Michael, one of our developer advocates, about the HIP process and how you too can be involved with that. We'll also have exclusive content from creators and builders in the community, such as May Chan from Hashpack, Sam Yan from Blade Wallet, along with representatives from other projects such as Web23, Turtle Moon Tools, and many others. We'll have some sessions that talk to developments in the Hedera naming service, launchpads, and DeFi ecosystems, where you'll get a chance to hear firsthand from key figures in the community about the systems and initiatives that you'll use all the time. Finally, there'll be some sessions that share best practices around security and sustainability. So think about all of those things that you wish you'd learned from day one to help you keep yourself safe. We'll also be diving into the environmental, social and governance, i.e. ESG frameworks and standards that are aligned with Guardian 2.0. So whether you've been in the community for a little while and maybe even contributed to our core code base, or if you're brand new to us, there's going to be something to learn for everyone. So let's look into the week ahead. We're going to be talking about wallets that we use every day to store our tokenized assets, Hedera naming services, i.e. the distributed DNS services, launchpads, accelerators and grants that help the projects in our community to grow and scale, NFTs, so whether you're a Hungry Baboons, Dead Pixels, or even perhaps a Hederian Dragons fan, there is such a massive range of NFTs in the ecosystem now. We're going to enjoy diving into those with you. We'll be touching on DAOs, or decentralized autonomous organizations, DeFi, decentralized finance, the swaps, liquidity pools, and farming protocols, to name just a few that have really lit up on Hedera this year. We're going to be touching on the ESG components, so tokenizing carbon credits, thinking about energy and water usage. Those focuses are only going to grow as Web3 moves forward and we focus on making a positive impact on the environment around us. We'll talk about security as well, so think about the procedures and protocols that we use as both operators of and developers of Web3 applications and how they can keep us safe. So let me break down the week ahead for you. Each day we're going to focus on a different vertical within the Hedera ecosystem. We'll have several timetable sessions that you can tune into. But don't worry, on day one, we're going to ease you into it with a rundown of the latest news coming out of Hedera, our network services and interoperability, along with a super important session from Leemon on the path to decentralization on Hedera. As we move into day two, you're going to hear from those builders in the wallet ecosystem that I mentioned before, so from Matt, Nay and Sammy. You're going to hear their stories and their latest news. You're also going to hear about the DDNS DAO project in the decentralized DNS space, where you can learn more about that and also about how being part of their DAO movement can help protect our futures as Web3 emerges. Then we're going to wrap up that day with lightning talks from the HBAR Foundation, Lumos Labs, Outlier Ventures, FPOS and Stacker by Tribe, operating all out of the accelerator and grant funding spaces. Moving into Wednesday, that's when we're going to talk NFTs. So we're going to hear from our very own Brady on the latest ecosystem metrics for Hedera NFTs and the current NFT landscape during the Hedera heatwave. Next up that day will be Patches, the developer behind Hashgraph Punks, Turtle Moon Tools and Hashgraph.io, talking about developer tools for building NFT projects on Hedera. And then finally on Wednesday, we'll hear from Michael Cantor, the founder and CEO of NFTia, where you'll hear about the advanced analytics that they compile so you can dig into trending mints and avoid FOMO. I think we all need a little bit of that. Thursday is all things DAO and DeFi. Our very own DeFi girl Mika will give us an intro into DAOs and DeFi on Hedera. Then we'll also have a peek into the DeFi accelerator at Swirlds Labs. Then to wrap up Thursday, we'll hear from Jesse Whiteside, the Director of Business Development at BCW Group, the builders of Hashport and Archaea, talking about the important role that bridges play, along with interoperability in the growth of our ecosystem. Finally, on Friday, we'll get into security and ESG. So Devon will kick off the day with an intro to ESG and security on Hedera for us. Then we're going to hear from Daniel from Envision Blockchain and Wes from the HBAR Foundation, and they're going to talk us through the Guardian 2.0, the open source ESG framework and ecological standards. We'll then switch gear a little into security. We'll be joined by Matt from Dovu for a session on security best practices for developers and degens, so make sure you tune into that one. Then to wrap up, you'll have the pleasure of my company to close out the week. So as we get through this week, make sure that you tune into the communication channels we'll have available for you. There'll be the AMA chat channel on Discord. We'll also be following tweets using the hashtag over Hedera Ecosystem Week. Make sure you engage and you share your thoughts as we get through the week. We look forward to hearing from you, and we hope you enjoy the week as much as we will. Take care.
Hey everyone, thanks for joining. I'm Michael Garber, a developer advocate here at Swirlds Labs. I'm going to tell you guys today about our Hedera improvement proposals, and we're going to look at what they are, the different types of HIPs that we have. I'm going to briefly walk you through the HIP lifecycle, and finally we'll wrap this session up by showing you how to submit a HIP yourself. It's really simple. You can do it in 5 minutes or less. So without any further ado, let's just get into it. HIPs. So what are they? Apparently they don't lie. That's a stupid joke. So HIPs are, it's an acronym for Hedera Improvement Proposals. And what they are is simply a suggestion for how to improve the network of Hedera. And they are markdown files that you submit in GitHub to initiate either an engineering effort or inform or align the community about some process or standard. But in all cases, the goal of a HIP is to enhance the network. And some of the attributes that make HIPs really cool is that being in Hedera and this decentralized network, we tried to keep this as decentralized as possible down to the improvement proposals. So they are community driven. They start as a suggestion, a discussion, either in Slack or Discord or one of our other channels, Twitter even, and then they kind of form into a more concrete definition of what the suggestion is. And a template is filled out that is a formalized markdown file of what a HIP looks like, and then a pull request is given with that template. Then that's it. Once it gets merged into the repository, you can track it on this HIPs tracker website that's located here at the bottom of the screen, hips.hedera.com. So some examples of HIPs that you may have heard of in the past. We have our JSON RPC relay HIP, which was 482. This was an application built on top of Hedera using Hedera services. And this gave users access to MetaMask. When we look at one of our community-driven HIPs that was championed by, I believe, Patches and oh man, you're gonna who did this? Anyway, a bunch of community members got together and created this NFT metadata JSON schema version 2. And I think Mei Chan was part of this too, and Ash Oro. And this just outlined a structure standard for metadata when you create NFTs on Hedera. And then we also have HIP 406, which is our staking HIP. Everybody knows it. Staking just went live with we in 3 tiers, and we're past the 3rd tier now. This rewards accounts for consensus contributions directly from your wallet. You don't have to lock up or anything. So we all know and love that HIP. These are some examples of HIPs. Far many more examples, but these are just 3 that I picked. So the different types of HIPs that we have, I like to think of HIPs, we have 3 different kinds of HIPs, but I like to think of them in 2 different categories. You have HIPs that touch the code base, and then you have hips that do not touch the code base. If they touch the code base, they require council approval. But if they don't touch the code base, if it's like an application built on top of Hedera, or if it's an informational type HIP, like the NFT metadata token schema standard, or it's a process like HIP1 is a process, how you submit a HIP, those don't require council approval. But if we're looking at the HIPs from those two categories, you have three defined types of HIPs that you will put on the HIP itself when you're making it. You're going to have a standards track HIP, an informational HIP, or a process HIP. And if it's a standards track HIP, I know this gets a little wordy, but under standards track HIP, that is a new feature or implementation built on Hedera or with Hedera. And in that you have the core, service, mirror, and application. So if it's a core standards track HIP, it touches this code base. If it's a service standard track HIP, it touches the code base and therefore requires council approval. Mirror, same thing. Application is different. It is a standards track HIP, but it is different because it doesn't touch the code base. It just uses Hedera it's an application built on top of Hedera. That's why it doesn't require council review, because anybody can create an application. An informational HIP, this is some design issue or general guidelines or standard that community comes and agrees on. That doesn't require council review either. It's just an informational type HIP. Anyone can make it. And similarly with the process type HIP, that doesn't require council review because it's a process surrounding Hedera. And informational and process HIPs, they are kind of related, but a process type HIP outlines a series of steps that is not really it's like a very, very strong suggestion of what you should do if you want to do X task or Y task. But an informational type HIP, you're free to follow it or not. So moving on, we look at the HIP lifecycle. Now, in the beginning, all HIPs start as an idea, whether you're on Discord or Slack or on Twitter even, you'll come up with an idea. Someone will come up with an idea to improve Hedera, and more people will talk about it. We'll create this discussion and start to form this idea of the HIP. Once that discussion is kicked off, the author or a champion of that discussion is suggested to go to GitHub and create a formal discussion on GitHub. So you would take your general idea that you've been discussing or that other people are discussing, and you go to the HIPs repo under the discussions tab and you create a new discussion with the same sorts of things that you guys were already talking about. And once that formal discussion happens, then a champion of that discussion will fill out a HIP template. The HIP template is located in the root directory of the HIPs repo, and we'll go over where that is and how you fill that out in the end. But for now, all you need to know is that's where it is, that's how you fill it out. Once the champion fills out this HIP, they put it from the status of idea to draft, and this is in this state the HIP has not been merged yet into the code, into the repository. It's just a PR or not even a PR yet, and this is in a draft phase. At this moment, the author has three choices. They can defer the HIP, and that means that some sort of work was going on already related to that specific idea, so they would defer that to that HIP. Or they can withdraw it, and that means that the HIP was just not feasible, whether it's not technically feasible or just really got a thumbs down from the community. The author reserves the right to withdraw it there. But if all looks good and the community supports it, everything's a green light, the author will change the status of that draft hip into review. And what this does when they make that status change to review is it signals the hip maintainer, which in this case is me, to look at the hip for any obvious errors and go over that hip with the rest of the engineering team over at Hedera. We meet once a week and talk about these hips. And then the hip maintainer will give feedback to the author. And if everything is a green light from there, the hip will go into last call. If it is not a green light, it can be rejected. But in the state of last call, a hip, it is a lot like last call at a bar, where it's a period of time. This period of time is 2 weeks, where the hip gathers any lingering community input, whether it's an issue with the design or, how we should more structure it to actually work. It's a period of 2 weeks that gathers any lingering input from the community. And after that 2 weeks, depending on the type of hip that it is, it can either go to council review, or it can go straight to accepted, or it can go to active. So a hip will go to council review if it touches the code base, like I was saying before. These are one of the 3 standards track hips that touch the code base. It either is a standards track mirror hip, core component, or service component. That will go to council review. If it's a standards track application hip, meaning it's an application built using Hedera, it will go straight from last call to accepted. And that means that the feature is ready to be implemented. Not that it's necessarily being worked on currently, but it's that it's ready to be worked on. And then, of course, final means implemented in code. If it goes from last call to active, that means this was an informational or process type hip, and it stays in that state. Once it's inactive, it doesn't ever change unless it gets replaced by another hip that either requires it or makes it better, improves on it. So that was a little bit of words, and thank you for bearing with me there, but that is the hip life cycle. So now let's get into the easy stuff, how to submit a hip. All right, so this is literally as easy as 1, 2, 3. Like I was saying, you create a discussion. All hips start with a discussion, and a champion of that discussion will come to the hips repository. They'll fork the hips repository. They'll fill out the template in the root directory, and then they'll submit it for review, and that's it. That's all they have to do. So I can show you all how to do that. If we go here, I'm here at the HIPS Hedera Improvement Proposal repository, and in the root directory, you'll see this hip template. So I'm gonna create first of all, let's fork this repo. So I'm in the HIPS repo, I forked it. Now you see it's brought me to my own fork. I'm going to go to this hip template, and I'm going to edit it. For the hip number, you're just going to put XXX. The maintainer will give a number to that. The hip title, let's call it a space hip. Author, this is just going to be, first name, last name, and then your email in these HTML tags. or these, I forgot what you call these little tags, but in between those, greater than and less than symbols. And then a working group, these are the a list of the technical and business stakeholders with respect to the HIP and the discussion. Here is where you'll put the type of HIP that it is. This space HIP will be a standards track HIP, and it's going to be an application standard track HIP because we're going to build a space HIP using Hedera. And since it's a application standards track and it doesn't touch a code base, it doesn't require council review. And for now, our status is in draft. Created date, you'll put it in this format. 11/7. Discussions, this will be the discussions that you created from going to the discussions tab and creating a new discussion. I'm not going to create a new discussion for this, so I'll just use an old discussion. And you put the link to the discussion you created here. Gotta make sure it's formatted right. And updated, don't need these because it's not updated. Don't need any of these right now. So abstract, 200 word description, cool space HIP that does stuff on Hedera. All right, motivation, and then we would of course say what the motivation is behind the space HIP. We want to send users to the moon, and that would be our motivation there. I'm not going to fill that out. The rationale. This fleshes out the specification by describing why the particular design decisions were made. And then, of course, a list of user stories of how the users will use this HIP. And then technical specification, which would be like, showing what the code looks like, the syntax of it, and all that sort of thing. And if there was issues with backward compatibility, or if there wasn't, then you would just note those here. Same thing with security implications and how to teach this, so on and so forth. If there are any rejected ideas in the discussion, you would note those here. So we're going to say all is well, and I'm going to say create space HIP to the moon, I guess. Yay. I'm an H barbarian. I'm here till 1,000 or 0, so. And then you sign off and commit the changes. And then I go to the pull requests. I'll submit, actually, I go to the Hedera Improvement Proposal main repo, and then I go to the pull request tab. And I create a new pull request, and I click this compare across forks because I forked the repo, so I have to compare across forks. And we'll do the base repo, which is the one we were at, hips, and with the main branch. And then we look at my fork, which is here. And then, of course, with my main branch, and you'll see the changes. It makes sure that this HIP is in the root directory, or make sure this HIP is in the hips directory. So I don't know if this is going to work, but yeah, Okay, cool. So make sure it's in the hip directory. You can do that by doing what I just did. You just do hip slash and then the name of your hip. And since it's a brand new hip, you don't have to do anything here. You can keep it like this, or you can do hip 00 and add a little descriptor like space hip. And this will signal to the maintainer, me. I'll look at it and see the name, and I was like, oh, the space hip, and then just make sure it's in the right directory. It has to be in the hip directory. All that's said and done, then sign off and commit changes. Now that it is in the hip folder, then I will make a pull request. New pull request, compare across forks. Go to my fork. And you see we had the original create space hip, and then we had the second commit where I changed the folder into the hip folder because the hip template, it lives in the root folder, but we don't want to submit our hip in the root folder. We want to submit our hip in the hip folder, so that's why we do that. And that is it. You create the pull request, say, please check this out, or whatever you want, a description and summary of what it is. And I'm not gonna fill all that out. I'll just create the pull request. And as you can see in our main Hedera improvement proposal repository, we have our hip from the fork that we made. And it is our space hip. Okay, so that's literally it. You create a discussion, you fork the repository, and you create a PR. As easy as 1, 2, 3. Now going back, we'll talk about some of the tips to submit a successful hip. When you're thinking about submitting a hip, what you want to do, the thought processes you want to have is you want to have your ideas as granular as possible. Hips that are technically clear and concise are favored by not just the maintainer, me, but the community overall, and they will be much more keen on supporting your hip if it's easily understood. If it is a big idea, we suggest that you break these hips up into smaller ideas, even smaller hips that might form a bigger hip, so they stay small and targeted. And in this way, you'll tend to have your hip supported by the community as long as it is a good idea. And if it is granular and easily understood, then you'll tend to have community support. And if you have community support, then that will literally move mountains with respect to getting your hip through the process. So that is it. That's all I would like to talk about with respect to the hips. Thank you all for joining. If you have any questions or concerns, my handle for Twitter is right here on the screen. I'm Michael Garber 87. I hope to see you soon or hear from you. And thanks for watching.
Hi, everyone. I'm excited to talk to you today at the Hedera Ecosystem Week on smart contracts on Hedera. And I'll try my best to give you an EVM capability overview and sort of give you an insight into our technical roadmap. So a little bit about myself. My name is Essilfie-Conduah. I'm a senior software engineering manager at Swirlds Labs and previously at Hedera. I have about over 10 years of experience working on an array of items from blockchain to consulting, device management, etc. One thing that I kind of pride myself in is I really like to enable others to get a tech understanding, especially in sort of decentralized manners, so they can equip themselves to build the software that makes their lives and others around them better. So a few of you will be aware of sort of the Hedera ecosystem. We're a decentralized ledger platform, proof of stake, and we're really prized to aim for different types of end users, individuals, enterprises, governments, and devices, and to really enable them to build different types of applications. And these may be in the kinds of, payments industry, it could be about decentralized identity, or even data integrity. And one interesting thing about our chain in comparison to others is that we have a decentralized governance model as well. And so our Hedera Governing Council actually is, a large collaboration of large globally decentralized companies that, usually may not come together, but for, the direction of the ecosystem would come together and sort of come to consensus on the direction that the Hedera Hashgraph consensus, mechanism, as well as the network overall, should be headed. And so, as part of the Hedera network, we have a couple of services that are able to be exposed to users. One of those is the consensus service that exposes, verifiable timestamped messages under separate topics, as well as the token service, which allows you to, natively tokenize different assets. And then, of course, the smart contract service, which allows you to execute smart contracts on the network. In terms of smart contracts themselves, a really quick overview or architectural view is what you see at the top. So you'll see dApps or decentralized applications. What they'll do is they'll make a call out to smart contract interfaces. And the smart contract code, as it were, lives within the Ethereum virtual machine, or EVM for short. And this gets executed within one form of a node or another within a decentralized ledger. And so you'll see that the EVM itself is sort of the brainchild, or the place where everything really happens. And so it's really a stack machine at its base, but it's able to process the opcodes from the smart contracts, as well as consume gas as you move along, and to make use of different variables within the stack and within memory. And so before I move forward, I kind of want to give you a sense of where the EVM on Hedera has been, where it is now, and sort of where we're moving forward to in the future. And so you could look at Hedera at its origin, maybe around end of 2019, 2020, and 2021. We had what we would call the smart contracts version 1. In this case, we were using an EVM client that was called Ethereum J. This was a Java-based EVM client. And also at that time, we were limited to only ED accounts. That means, accounts that used Edward keys as their cryptographic key. And also then by design, we sort of limited the network to focus on native assets and, tokenization through the Hedera token service. We really believed, and even still today believe, that when it comes down to tokenization, you're able to do a lot more outside of smart contracts. And so then, the focus was more of applying a base layer of smart contract execution, but providing the actual power and additional benefits within HTS. However, we heard from the ecosystem, we also watched the market, and we understood at the time that we were compatible, but this notion of equivalence came along, where regardless of which EVM chain you're on, if you run a smart contract on one chain, taking Ethereum, for example, the goal would be to be able to bring that to Hedera and have it run the same way. One issue that we hit was, Ethereum J stopped being supported, and so we weren't able to keep up with the offerings of the EVM. And so we really knew that we needed to focus on equivalence. The next step was then, you would have heard announced earlier this year, smart contracts version 2. And so with that, we brought, an increase in performance, over 10 times performance bump as in comparison to Ethereum. We also maintained our carbon negative, roadmap there. And so even with the proof of stake, the energy that we do consume, we also buy offsets to ensure that we stay negative. But also one of the biggest benefits of Hedera is the predictable fees. And the way in which we obtained this was we migrated away from the Ethereum J client that I mentioned before over to the Hyperledger Besu client. And so there, this brought us, again, Ethereum virtual machine compatibility, but it brought it up to modern day. And so with that, we're able to have the same compatibility with, say, the London fork of Ethereum. And so developers are able to bring their smart contracts over from, say, Ethereum to Hedera and have the same expectations of how their smart contracts function. And you're able to use the latest Solidity version as well. We also implemented a couple of HIPs. I'll mention the numbers, and for those who aren't familiar with them, I'll give you a bit of a idea of what they entail. So we implemented HIP 185, 218, and 329. And really what we did there was we first separated the throttling away from the transactions per second. And so previously in smart contracts version 1, you had a specific number in which you were limited to in terms of the number of transactions that could go through in a second. In smart contracts version 2, we do this base of gas, and this allows a lot more transactions to go through based on how much gas is being consumed. It also allows for the smart contracts execution to be scalable as the network gets faster, as we scale out the execution and the number of transactions that can be performed, but also how quickly we execute them can scale with the network. There was also one item in version 1 that we didn't have, which was the ability to use the create2 opcode. And so this was added, and this is used widely in many smart contracts. But also a big item was the ability for contracts themselves to own tokens. And so you could imagine that you could create, say, an HTS token and have a smart contract itself own the token and be responsible for whether it was minting or burning. We also implemented HIP 206, 358, 376, and 514. And this was really to integrate HTS into the EVM itself. And so as you would have recalled, I mentioned that HTS gives you a lot of extra capabilities in terms of being able to natively manage your tokens. But as I said, we heard from the ecosystem and we decided to integrate this into smart contracts themselves. And so through a smart contract, you're able to actually transfer, mint, burn, associate, and disassociate tokens natively created, but through smart contracts. Additionally, you can even apply management functions and operations such as KYC, being able to freeze the token or pause them as is necessary for your application. And one big request that we had from the ecosystem was, developers have this familiarity with ERC20 and ERC721 tokens. And so though the Hedera token service offers fungible and non-fungible tokens, some developers will be used to and may have written code on other chains that already use this concept. And so we decided to add the capability to treat your HTS tokens as if they were ERC20 and ERC721. And this is a game changer for a lot of developers because they're able to take their existing, test code or interaction code and, move this over to Hedera and have it still work the same way. Be able to ask for the name, the symbol, balance, and other things using the same sort of interfaces that they're used to. We also implemented HIP 260, 226, and 227. And this was really around traceability. The notion of I've executed my smart contract, but I want to know what went on. And so through these efforts, we were able to expose the runtime and the compile time bytecode, the state changes that would have occurred within the smart contract if you overwrote a variable within the smart contract, that would be exposed as well. And also the actions, which really talks about how one contract interacts with another. And so with this, developers are able to troubleshoot and really just understand from the smart contract execution point of view what happened, what changed, and really work backwards if they need to look deeper into what happened. We took the extra step of also exposing that via the mirror node. And so today's REST APIs on the mirror node will expose that traceability information. And because of that, explorers built on top of the mirror node themselves can sort of aggregate this information and provide you more sort of detailed information around the execution parameters there. One big announcement that we made early in the year is the JSON RPC relay. And so this was a missing component that some developers might have seen if you think of a node on the blockchain or a DLT as it were. And so in other chains, there's an RPC API that you can interact with. And so we released our JSON RPC relay. And what this really allows for is for developers on EVM chains to effectively interact with Hedera in the same manner that they do on other chains. And so what you might see is that web apps or dapps, wallets, libraries, and tools will effectively see this sort of EVM interface that's placed on top of Hedera. And so we'll be able to interact with the mainnet nodes as well as the mirrornet nodes through the same calls that they would make on, say, an Ethereum chain. So transactions can be submitted. And one really cool item that we did here was that we took the concept of, not reinventing the wheel, but Ethereum and, the EVM, as it were, encodes transactions using the RLP encoding standard. And so instead of, unwrapping that, what we decided to do was rather just wrap that within an existing Happy or Hedera API transaction. And we're able to submit that to the mainnet. The mainnet is then able to use the logic from, HIP 410, as well as the blocks concept from HIP 415, and all the information and capability that we brought with the smart contract service to process these new transaction types and give that equivalence with other EVM chains. On the other side, we're also able to support queries for, say, balance or even smart contract bytecode by calling the mirror node on the back end to get the information that's needed. And so from a developer standpoint, using the JSON RPC relay, and whether you're coming from MetaMask, Ethers.js, Web3.js, Truffle, or Hardhat, you're able to interact with the Hedera nodes the same way you would, say, Ethereum nodes. And this opens up a lot of possibilities, and again, allows for equivalent experiences for developers. So I've said a lot and showed you a lot graphically, but I thought it would be really cool to show some code as well and run you through what I would say is a very simple sort of smart contract lifecycle demo. And so what I'll aim to do is show you a quick contract development process related to the ecosystem week. I'll also highlight an HBAR transfer and also a quick interaction with MetaMask as well. And so for the purposes of Ecosystem Week, what I did was to push a README with some information that you can follow. And so if you head over to the Hashgraph repo on GitHub and under the Hedera Smart Contracts repo, I actually pushed a branch that's Ecosystem Week. And so you'll be able to follow on the details that I'll go over here. So one of the first steps you want to do, of course, is to obtain an account. And so the way that you would do that on the Hedera testnet would be by going to portalhedera.com, and you would register and follow instructions to obtain an ECDSA based account. There's also a really useful blog post here that one of our developer relations engineers was able to highlight. And so that sort of just gives you an overview of what to expect as you're creating an account. So Ed showed this over here. So you can expect to create that test account. You'll get by default an ED2 key, but what you want is to create an ECDSA based key and use the private key that is then shown to you. So I'll leave that reference there in the README for others to look at. Then, of course, you would want to clone this library or this repo, the Hedera Smart Contracts repo, and just do the expected npm processes. So you'll do an npm I to install the libraries, and we're using Hardhat for this development process, and so you'll want to run npx hardhat compile. One of the really cool things is using Hardhat, you're able to point to the Hedera testnet RPC. And so the way in which you would do this would be by configuring a file called the hardhat config.js. And you're going to go ahead and add the testnet entry into the list of networks. And so under the testnet item, you're going to populate the URL with the testnet hash.io URL. And so just to mention here, hash.io is the Swirlds Labs hosted version of the JSON RPC open source code. And using the account that you obtained earlier, you'll want to populate this list of accounts based on what you got from the portal. And you'll want to set the chain ID to 296 as well, and set the default network to testnet. But let me go ahead and move over to the code to show you what that looks like. So under the repo, you'll find the hardhat config.js file that I mentioned. And when you come in here, either if you're using the branch that I pushed, you'll see that most of this information is already there. But if not, you'll be setting the default network to testnet. You'll be adding the testnet URL and the accounts and the chain ID. The next step that we want to do is actually to create a new contract. So I figured one really cool thing that we could do for the ecosystem week would be maybe create a contract that, assigns you a token when you acknowledge attendance of the ecosystem week. So in this process, what I'll be using is the process of using the actual Hedera token service that I mentioned before through smart contracts. So I'll give you a quick overview, and then we'll go over to the code as well. And so for those of you familiar with smart contracts, you'll notice the Solidity file as the Solidity compile version. We're also using experimental ABI encoder. And here we're just importing some files that are made available to you in the repo. And they really just make a couple of things easier. And so most of these are wrapper contracts that you can use. One cool thing you'll see is that we're also able to use OpenZeppelin's IERC20 smart contracts. And so really what this smart contract does is it inherits the Hedera token service as well as the key helper. And I'll go ahead and sort of give you an overview of the extra items that I've added. So we'll be creating a HTS token. And so I've set here the name and the memo, as well as the desired max supply, the decimals, and the default status. And these are just some events that we can log to highlight what's going on. And so in the constructor, you'll see when the contract is created, we go ahead and assign the owner as this contract's address. We also set the initial supply and the token symbol. And then we set a couple of other items for the token. So the name, as I mentioned before, the symbol, the treasury, and the expiry. And then really just using this one line here, we're able to tap into the native Hedera token service and create a fungible token using the token properties and other items that I mentioned before. We're also able to quickly assign the HTS address that we'll use later on. And then here's the kind of the fun part. So I added a function that says I attended. And by anybody calling this function, we go ahead and do an associate token. So since the user will be submitting this is them saying that they want to associate with the token. And assuming the association goes through, we also have a check for if the transaction itself didn't go through. Maybe you had already associated. We want to make sure that there's only one token assigned to anybody that attended. And so we have that check here. We're then able to go ahead, and the contract itself is able to issue a transfer of the token. So you'll see that we're telling it which token address. This is the owner, which is the contract that we mentioned, and this is the message sender, which is the initiator of this transaction, which will be you or myself if we were to call this contract. And then we go ahead, of course, as well as in just emit a transfer token event just to give a bit more information. And then we return true. And then I added two extra functions to highlight what I mentioned earlier. You'll see here, I'm utilizing the IERC20 metadata as well as the IERC20 contracts from OpenZeppelin. And so using this, I'm able to effectively treat the HTS native token as if it was an ERC and get the symbol right out of there without writing too much code. And the same thing for the balance. And so switching over to the code, you'll see sort of the same representation of what I highlighted there, the same functions that we plan to implement. And as I mentioned, if you're looking at the ecosystem week branch, this code will be there for you. But if you wanted to follow along, you could do that too. And then the next step is we're going to write a quick test file, which is actually going to do the deployment of the contract as well as the execution of the functions that we mentioned. So I'm just using the chai tooling framework, and in the before method, we're effectively just deploying the contract. So we get, for those of you familiar with Ethers.js, we get the contract factory, we deploy that factory, and then this is just getting the receipt of the transaction to be able to pull out additional information. I also went the extra step to sort of put together the URL for Hashscan so you can see some useful information in the command prompt. And so this will give you the URL for which you can go to Hashscan to get more information on the contract that was deployed. And we store the contract address so that we can use that later. And so in the first test, we basically do a quick check to make sure that the balances of the affected accounts and contracts are what we expect them to be. So we expect the contract, which essentially in this example serves as the treasury, to have the total supply. You recall from the smart contract code, when we created the code, we also set the total supply. So we'll expect the smart contract itself to have a balance of this total supply. We'll also expect any other addresses that we noted in the hard hat config to have a balance of 0. The second test just verifies that the symbol is what we expected it to be. And so we had the symbol being set to ESWT. So we'll expect that when we query the smart contract, it will be what we expected it to be. We'll then try and go ahead and say we attended ecosystem, and so I would make this call, or the signer would make this call, and we'll be able to get a bit more information about the smart contract execution at this link that will get pasted out. And after having said I attended, we'll just want to make a quick check to say that the balance changed as we expected. So you'll see that the smart contract treasury itself, we'll expect the total supply to be 1 less, and the account for which we submitted to be 1 more, and just checking that the other accounts aren't affected. And then finally, we'll do an extra check just to make sure that I can really only attend once. So if I submitted and I attended a second time, I'd expect this to fail. And so again, you'll find this under the test section, under the HJS file, and this should map to everything within the README. And so to execute this, we're just going to do a hard hat compile, and then we'll run the npx hard hat test, and then we'll look at the execution details. So I'm going to switch over to the command prompt and show you that. And so assuming that you already did a hard hat compile, you had everything set up, we're going to go ahead and run this. While we run this, I'm going to take the liberty to switch over to MetaMask and show you what a quick HBAR transfer looks like, so you don't have to wait on this. But I'll kick this off and we'll come right back. And so let's go to MetaMask and see what it would look like if I had already added my accounts. So from the portal, you got your private key. You could come into MetaMask and import that. And so you'll see that in this case, for the testnet account, I'm able to point it to the RPC, the JSON RPC relay, just as I had shown you before. But if you want more details, what it would look like would be in hard hat, you would add a new network. You can give it any name that you want to. In this case, I called it the Hedera testnet. I would fill in the RPC URL. In this case, I'm using the Swirlds Labs hosted version of the RPC relay at hash.io. So that's testnet.hashio.io/API. The chain ID, as I had mentioned before, was 296. And I decided to go ahead and set the currency symbol as HBAR. An additional feature that we did since deploying the version 2 of the smart contract is that we added support to Hashscan to serve as a block explorer. So you're also able to put that block explorer URL in here as well. And so having that all configured, let's say I wanted to send someone HBAR. So just as you would with a normal MetaMask execution, I would press send. In this case, I have some other accounts. So let me just select one of those. I'm gonna go ahead and say maybe send 3 HBAR, or let's say 30 HBAR. I'm gonna go to next, and you'll see that the gas prices are set. There's an estimated gas price, and then I'm gonna go ahead and click confirm. And so you can see that this is loading, and we go into a pending state, and then any second now it should turn to success, and we should be able to see that HBARs were transferred to an account. And there we go. So 30 HBARs were sent. I didn't count that, but I'm pretty sure it was under 10 seconds. And the point being there that, on the Hedera network itself, consensus probably happened under 2 seconds, but sort of going from the whole ecosystem, including MetaMask making a lot of calls, you'll have some additional latency there. But you'll see that 30 HBAR was sent. And if you wanted to check more details, you could click on that. Click on the View Block Explorer, and right in Hashscan, you'll be able to see the details for this and see that, I sent this account a certain amount of HBAR. All right, so we'll see what that looks like when I put it into Hashscan. And so you'll see here the contract was created, and these are the details. And you'll also see a list of recent transactions for that contract itself, and some more details about it itself. It even shows you the transaction on Hedera that actually created it, and a bit more information, like its balance and other items. So we also have the HTS token itself that was created. We can get a bit more information about that token. So you'll see that we did indeed create a fungible token, the name Ecosystem Week as we expected, the symbol, and all the items. And you can see when it was created, modified, total supply, initial supply, all the items that we had configured in the smart contract code. We'll also want to take this ERC20 address. This will come in handy in a moment, and I'll show you then. And let's see. So this is the transaction for me successfully attending the event. So let me open another tab for that, and let's see what that looks like. So you can see here, this is the contract result. In similar, we want it over here on Hashscan. The team did a lot of work to provide a similar experience to what you might expect on, say, Etherscan and other items. So you can see, the result, any error message information, the from and to, the amount of gas consumed, and the type of transaction. But as I mentioned, through traceability, we've also exposed the ability to see the different state changes. And so you'll see the actual slot address on a given contract, what was read and maybe what was written, but you'll also see the logs information as well. And so we'll also see an instance of a failed transaction and what that looks like. So in this case, you can see that the contract execution was reverted because we only wanted to support one token per person. And so that was the details from the contract execution. So the last thing I wanted to show you was taking the ERC20 address of that token. I'm going to copy that, and then I'm going to go into MetaMask. And as you recall, the contract sent me an HTS token. And so using MetaMask, I'm actually able to add that as an asset using the import tokens. And so I'll paste that address over here. And you'll see that using the relay, it automatically implemented and filled in the token symbol and then the decimals. And if I add that, you'll see it's already able to pick up the fact that I have one token that was sent to me, and that was the balance. And so now my MetaMask asset shows this HTS token that was added. The same would happen if it was an NFT token. And so that's the end of the demo there. So I'm going to switch back to my slides and sort of highlight the rest of the roadmap. So at the top, you'll see for 2022, a lot of the items I mentioned there, the JSON RPC relay, the hosted version of the beta release of that through Swirlds Labs. We did a lot of work to support developer tools. As you saw, everything I did was there through Hardhat and Ethers.js. And so the team did a lot of work to make sure that the calls being made by the tools work efficiently on the JSON RPC relay. You'll have seen the block explorer items on Hashscan that I just showed you. And even the ability, like I just showed you, to send and receive certain assets using ETH addresses that I showed you in MetaMask. And so for 2023, we have a sort of a jam-packed schedule, and there's a lot to be done. We'll continue to make efforts and advancements towards sending and receiving ETH addresses, and really making the onboarding experience for developers really clean and simple and, as I said, equivalent and comparable to other chains. There's a bit more items that we can do on the block explorer, again, making it similar to what people might see on Etherscan where it makes sense, and providing that compatibility. There's also some end user work that needs to be done in terms of how accounts are represented on the EVM itself. One note there is by nature of the EVM, accounts are ECDSA based keys. But out on Hedera, we're able to give you support for additional key types like Edwards, as well as complex keys. And so we're doing some ironing out there to provide that clean experience and to allow you to still execute smart contracts and have the assumptions that you would of the EVM, even if you have these other types of keys. There will also be some ecosystem development work for tools as it makes sense. We definitely want to support, the big ecosystem tools that the developers and retail users are using. One big item that is missing from today is the EVM archive node. And so the RPC today does support queries, but on other chains, most of these queries are support simulations as well. To date, we don't support the simulations through the RPC. With the EVM archive node, what we're effectively doing is adding a component to the mirror node that allows you to make queries that would be simulated. So you could see in advance what would happen if I executed this smart contract execution, but also you'd be able to do more fine-tuned gas estimates. We'll also expand the RPC API itself, looking into things like debug methods and other items that are expected from tools. And then finally, one big item would be more Hedera system contracts. And so there are some HIPs out there already, and some in the works, where we will continue to expand the smart contracts offerings and expose native experience, native entity and transaction experiences to smart contract developers. And so again, if one of the items I definitely want people to take away is today and for a while, we've been EVM compatible. We provide the experiences for developers to be able to bring their smart contracts over and execute them. But what we're really aiming for is equivalence, where you can have those same expectations of the EVM that you have on other chains and have it here, but also again, take advantage of the additional Hedera benefits that only we can offer. So thanks for watching. And, I definitely want to take the time to say my team is hiring. So if you know any engineers and developers out there looking for a new gig and are interested in smart contracts in our ecosystem, definitely send them my way. Thanks, and enjoy the rest of the Hedera Ecosystem Week.
Hello, welcome. I am today sharing with you the state of our ecosystem, the state of decentralization, the state of Hedera, just what's going on. I thought it would be useful to give an update on sort of the big picture of where we are and some of the things about where we're headed. So let's get started. Our ecosystem right now has lots of very cool things that have happened over this last year. We have decentralized the organization in some fundamental ways. So there is Hedera, which is the governing council, and then we've split off Swirlds Labs, which is where I'm CEO now. I've left Hedera as an executive. I'm now at Swirlds Labs. And then I'm still, as Swirlds as a member of the council, just one of 27, I can still be in the committees. So I'm still involved in the committees of Hedera. But Mance and I have left Hedera as executives. And so we are decentralized and we have no power over Hedera. We're just in the committees, and I'm a chair of 2 of the committees. But we are just one of 27 now, and anyone could be a chair of those committees. I'm having an election right now for that. And so we have decentralized in that way. The founders are now separated from the governing council, which is good. And the founders are CEOs of Swirlds Labs, and we are working on the Hedera ecosystem across the board. So we're doing lots of the code for Hedera, we're doing marketing, we're doing all sorts of things to build the ecosystem, but we are doing it from a separate, more decentralized organization. So that is how we're separating. Hedera itself is the council. It is still doing on-chain governance of the code updates and of the fees and of the rewards and of the membership of the council itself. All of these things happen in meetings where they talk to each other and they publish the minutes. But then to make it actually take effect, transfers of tokens, that's another one. To do any of those things, to transfer the tokens, to update the code, the council has to digitally sign a transaction that goes to the network to make it happen. And so every time there's a code update, every time we change fees, transaction fees, or rewards to nodes, or staking rewards, or who is in the council, or transfer some HBARs from Treasury, the council has to sign. And a majority of the council members, the 27 council members, have to sign to make that transaction work. And so it's on-chain governance by a decentralized council of 27 completely unrelated companies and universities, top 10 in the world universities, 3 of them now. That is how we've separated out Hedera and Swirlds Labs. But we've separated out more than that. We've separated out the HBAR Foundation to be giving grants and the Hashgraph Association, which does grants and also is doing education and certification, and the DLT Science Foundation, which is doing research and publications and these things. These are all separate organizations now, and there's no shared leadership between them. They're decentralized. This is a big deal, and this has happened only recently. We've been working through all the details of this over the last year. We have now open sourced all the code. For a long time, we had most of the code's open source, but the bottom layer was not. Now it's all open sourced, top to bottom. You can run private Hashgraph networks if you want, with a clone of the Hedera software. And we're doing that because we now have this critical mass where it would be hard to just spin up a competing ledger to hurt it. We also will have state proofs with ledger ID, so no one could ever pretend to be us. And we currently have the first version of state proofs. A mirror node knows for sure that it is getting what it needs from Hedera and not some other clone of it that's fake. So that was the concern from the beginning, and that now is completely ruled out. A mirror node knows for sure that it's talking to Hedera. So we've open sourced all the code, and I'm excited about what will happen with that and see what the community does with that. We have enabled staking. That's the most recent big project, big change that we've made. You can now stake to Hedera, you get rewarded. And so this is another part of the decentralization, as everyone is staking, that controls the security of the network. And we're going to get to the point where even without permission nodes, we'll still have security because of the staking. And so we have rolled that out now. People are getting rewards for staking. And then we have next projects coming up. Now that we've done the staking, which took changes to the code, and then we had to look at regulatory things, and we had to look at the market and help other tools get ready. Now we're doing all the same things for community nodes. We're looking at the code and regulations and helping the community get up to speed on it, and we'll be able to we'll add a few, and then we'll add a lot more. And so we'll be doing that over the next 12 months. This is what we're doing this year. Coming up is working on community nodes and DREC. That's the other thing over this coming year that we're doing. So this year we'll be doing DREC, which is decentralized recovery. If you lose your key, how do you get it back? Well, you have some helpers that help you. But how do you make that secure and super easy to use so that people even outside of our community, you can have your grandma being able to do this. And so we will be talking a lot about DREC. So this is sort of an overview of some of the things we've done over the past year and some of the things that we're about to be doing this year, this coming year. And so let's talk about those. What we need is decentralized governance. We have the best. We have the best decentralized governance. It's not like other ledgers where you find that a dozen pools have half the hashing power, or the majority of the hashing power. It isn't like other ledgers where 6 parties have the majority of the stake, and 1 party has a third of the stake. And huge fractions of all the nodes run on Amazon, so you have 1 company with control. We don't have that. We are decentralized in our governance. We have 27 separate entities on different continents under different governments in different industries. They are huge trusted names. They keep tabs on each other. They include some of the top universities in the world. They include some of the top companies in the world in different industries. There's tech and there's finance and there's banking and there's all sorts of different things, legal, different kinds of companies and organizations in it. So we have very good decentralized governance. And we continue to do that. We continue to add council members. We continue to decentralize. Aberdeen, I think, was the most recent one. Very excited about that. And their use case is exciting too. New council members coming in come with really good use cases. We need network utility. We have that. We have a very fast, very reliable network. And it is ABFT so that you can trust it. And it has all of these features. It has smart contracts that use Solidity, so it's industry standard, and we're building all these tools around it, but it can also take advantage of existing tools. And we have the consensus service, which allows you to store information immutably forever through the ledger. And you can do that for 1/10 of a cent per information that you're storing. Very, very cheap, very fast. Denominated in US dollars so that the price of the transactions doesn't even fluctuate over time. Very important for businesses to be reliable on what the pricing is. And we can go up to 10,000 transactions per second. If we get right up to the limit, then the prices all go up. But if we really get up to that limit, we'll raise the limit. And if we even get to much higher limits, we'll eventually go to sharding. But right now, that's not a danger. 10,000 is far more than we need at the moment. And so we will increase that as we need to. So network utility is fantastic. We have very secure nodes. They are being run by the council. They'll soon be run by community members as well over this coming year. And then also they are ABFT. You have all these math proofs. You have these state proofs so that a mirror node knows for sure that it is getting the true consensus of the network. And we'll soon be coming out with this coming year with state proofs that allow individual people to find out that a particular question they ask is true. What's the balance of my account? You get an answer that's cryptographically proved that it was the consensus of the network. And then, of course, currency distribution. We've been distributing the currency, especially through things like the HBAR Foundation. And then people now that have the currency out there are starting to stake. And so that helps then true with, in addition, with the security. So we have the currency distribution. So these are some of the things that are going on right now. You know it's built on Hashgraph, which has all sorts of advantages in speed, and it's leaderless, which gives you fairness advantages and DDoS resilience, all sorts of really good things. We've talked about this many times, but it's fast and secure. It has math proofs that have been checked by computer. Carnegie Mellon did that, all sorts of things. We are secure as long as any of these things is true. So as long as we're permissioned, we're secure, and we are permissioned right now. You would have to compromise 9 out of our 27 members in order to do anything malicious. No one member by itself can do anything malicious. You have to compromise a third of the network. And even someday when we go to non-permissioned, we'll be secure if the staking is widely distributed, and if there is a high circulating cap, then it becomes difficult for people to attack the network because you have to corrupt a third of the stake in that case. And so the fact that we've started staking now is encouraging. The fact that I see lots of people staking is encouraging. And this will just continue. And so right now we're permissioned, so it doesn't matter, but we are setting this up for the security of the network. When we're no longer permissioned, it will matter. And I'm very pleased with how we've progressed on that this year. Starting staking was great. And as I said, we are proof of stake, but we are leaderless proof of stake. This is important. You can have a proof of stake system where the computers take turns being the boss, and if somebody DDoSes the boss, if they do a distributed denial of service attack on the leader, then they shut down the whole network. And you could say, well, fine, we change leaders every few seconds. Yeah, but if you can predict who the leader will be, then you can follow the leader and still shut down the entire network for as long as you're doing the attack. Now, of course, if you can DDoS every single node on the network, you're going to shut down any network. But you really don't want a fragile network that can be shut down by shutting down one node. That is not a good idea. And that's one of the problems with having leaders. There are some ways of doing leaders where you're not vulnerable to the DDoS, but you still have fairness issues because a leader can arbitrarily decide to delay your transaction, and there's nothing you can do about it. You don't choose your leader, and if they want to delay your transaction and let your competitor get their transaction in first, front run you, all those things, you have a problem. We are leaderless, which means no one node has the ability to delay your transactions. Once they are gossiped into the network, no node can stop you. Now, if you send it through a particular node, you could say, well, that node could stop you. Sure, but you could just pick a node that you trust. You get to choose the node, or you could run a node, or you could send it to multiple nodes, and then if even one of them is honest, you're okay. Nodes could have reputations based on whether they delay things or not. So because you choose who submits you, that doesn't give you this fairness problem. We have a fairness of access in that. And then once your transaction's in the network, no one node, no small group of nodes has the ability to delay you too much. And so it is fair in the ordering that we put them in, and it's fair in the timestamps they get. Very important. Also, just because it's Hashgraph, it's incredibly efficient. I don't have a slide for this, but I've shown this in other videos. The UCL report said that we are far more energy efficient than any other of the major ledgers. We're even 100 times more efficient than credit cards. If you use your Visa card, you're spending more than 100 times the carbon into the atmosphere than we are. You're dumping more than 100 times as much carbon as we are. And then we also buy carbon credits so that we're carbon neutral, and then we buy even more so that we're carbon negative. But the best thing to do is to not dump the carbon into the atmosphere in the first place. And we are by far the best of all the major ledgers for that. We have decentralized governance. And I talked about this. We've always had decentralized governance, and we just continue to grow. So we're up to 27 now, and we're still growing. We'll go to 39. And so, we haven't talked about this in a while, but we had this slide in the distant past, but I think it's worth remembering. What's up with this? You need to have high trust in your governance model. And if your governance is for a project that is complex, then you want to be able to deal with that complexity. So how do you do that? Well, if you have no decision makers, then you really don't have any trust, you don't have any complexity, it can't handle any complexity. If you only had one decision maker, a king, a leader, in that sense, then you could handle high complexity, but you wouldn't have any trust. So you'd be high in complexity but low in trust. If you say everyone in the world who holds a coin can vote, maybe you would start to have great trust. Maybe you wouldn't. I'm not entirely sure you would have a huge amount of trust, but you certainly couldn't handle high complexity. The average person holding a coin doesn't understand the very subtle issues that are involved in a ledger. What you really want is to have multiple decision makers who are trusted. They're keeping tabs on each other, so it's not just a small group. It's like the 27, and it are people who are you would expect would know what they're doing, because they've been around for a long time and they're running multi-billion-dollar businesses or a top 10 in the world university, these kinds of organizations. So they know what they're doing. They have a name to protect, so they have a strong motivation not to do anything bad because they will get caught. And they know one of them has the power. I wouldn't trust any one of them to have the power. Never. But they all keep tabs on each other. And so a majority of them have to agree to do anything. So this is what you want. You want a governance model where the power doesn't get consolidated. And I said, if we let every coin in the world happen, what could happen is you end up with whales and then they have all the power. We want to avoid that too. So the council is by far the most decentralized of the major ledgers right now in the way it is doing governance. It is not a handful of developers that kind of rose to the top and now really control the code. It isn't a handful of mining pools that have all the hashing power. It isn't a handful of whales that have all the staking power. It is very decentralized. And this is a good thing, and we will continue to do this. We will continue to add council members. We will continue to make this something you trust. And we will continue to do that for the next 100 years. And then there's this red arrow. You could have a system like ours, but if they can't enforce their decisions, it's the same as having no governance at all. And so we have a system where when they sign the majority of the transactions, all the nodes do upgrade their code base. And if anyone fails to upgrade, they can't play as part of the system. Now, people can always fork and create another ledger, but they can't get our ledger ID, so they can't pretend to be us. So as long as you want to be part of Hedera, this ledger, you have to play by the rules. And that means that you allow the council to upgrade the code. We have strong governance, and you can't fork the network because we have the state proofs. All these technical things ensure that we have strong governance. So with a council of 27 nodes, you know this, we're going to go up to 39 is the plan. We're on all the continents except Antarctica. We've got to work on that. And we're not in orbit either. We've got to work on that too. But we have a huge distribution of these, very spread out. It's DAO-like governance in the sense that it's on-chain governance. And each member has an equal vote. There is no whale that has a huge outsized vote. Everyone is the same. We have these 5 committees. I mentioned 2 of them that I'm involved in, and there's several others as well. And there's a 3-year maximum term with up to 2 consecutive terms. That clock starts when we get to 39 or maybe even earlier. We'll see. And members selected by the council membership. So one of the things the council does is chooses the further council members. By the way, that wasn't true originally, but that was one more thing that over the last year or so we have changed and made more decentralized, and now the council itself is choosing the new council members. Clearly you couldn't do that for the first couple of council members, but now we have enough that we're even doing that. So even that is decentralized now. Here are the 27. I love it. Aberdeen's up there in the upper left corner. That's the most recent one. We have universities, we have banks, we have lawyers, we have tech companies, we have aerospace, we have financial things and payment systems, everything you can imagine. Magaloo is a store, an online retailer, and a brick and mortar retailer, all sorts of different things. This is the governing council. Network utilization, we have our network, we have the 3 services that I mentioned. Oh, I didn't even mention the token service. I love this. If you want to, you create a smart contract that has ERC20 or ERC721 or whatever, and then that's very, very flexible and powerful. But you know what? If you want extreme speed and very low cost, what you do is you use the native token service. And that's very cheap, very predictable in its pricing, 1/10 of a cent to move a token, even if it's $1 million token, it's 1/10 of a cent to move the token. And that then is very fast, very cheap, but it interoperates with the smart contracts. So a smart contract can reach out and do things with the tokens. And so they can work together. So you can use the smart contract when you need the power and flexibility. You can use the tokens when you don't. That's our tokens, how the token service works. Then we have a huge number of applications and a huge number of different kinds of end users. This is a tiny part of the ecosystem of all of the governing council in the upper left, the different Web3 ecosystems and applications. You can see them broken down by metaverse and gaming and ESG and payments and stablecoin and tooling, all these different categories, enterprise applications, all sorts of different industries, different types of applications, tooling integration, lots of tooling, lots of integrations with other things. We have the grants and the accelerators that we talked about earlier, and you can see some of them down there, the two I mentioned, and then others also. Industry associations that we are part of. We have plugins for things like Hyperledger and Corda and EEA, and we are part of others, W3C and others. In fact, for DREC, we're going to be doing standards to organizations, working with others to submit standards. And we have wallets and custodians, enterprise applications. This is an enormous ecosystem. I love this picture. And this picture is the tip of the iceberg of what is going on in the Hedera ecosystem. It just further decentralizes over time, further becomes powerful. Wide distribution of HBARs. HBARs, of course, are the fuel that run the network. You have to use HBARs to make a transaction, and they're for network protection. And now we have staking and staking rewards, and people are encouraged to stake to the network, to choose a node they trust. And so we can then have people voting for which nodes they trust. And there's a min and a max so that you can't have all one node becoming the whale. But if any node doesn't get enough of staking to it, it drops off the network automatically. No human involved. It just automatically happens. And so this is for the protection of the network. This is for the security of the network. We do staking right. There is no bonding or slashing. You have an account, you stake it to a node, and you get rewards. And at any moment, you can spend your coins if you want. And until you spend them, you're getting rewards every day. You're earning rewards every day, I should say. The reward is the maximum, right now, it's the maximum of 6.5% or 1 billion HBARs per year, divided over 365 days, divided over everybody who is staking. The rewards can be triggered by anything that touches your account. And so anything you do will cause a reward to happen, including when we someday turn on rent, your account will automatically auto-renew once every 3 months, which will trigger a reward at once every 3 months. And so you could get a reward every day if you're doing lots of transactions, or you could get a reward every 3 months if you wanted to. It is interesting. There's not much of a difference between that, actually. Compounding daily or compounding once every 3 months is not a big difference. It's like 1 part in 100 in how much you get. But, it's nice to compound frequently, I guess, but it's not a big difference. It's almost the same if you compound once every 3 months. And that will happen automatically when we have rent someday. So that's cool. When we have auto-renewing, the auto-renewing itself will trigger the rewards. But for right now, it's whenever you do something. Don't worry about missing out on rewards. As long as you do a transaction at least once a year, you're going to get your rewards. Once every 365 days, you'll get your rewards. So if you do go over more than 365 days and have never touched your account, then you have lost out on older rewards. So, do something every year, but I don't think that will be a problem. And when we have rent and auto-renew, then it won't be a problem because it'll automatically do it. Let's see. And when it's enabled, yes, it'll happen every quarter. We have staking, I said. Lots of people are staking now. Hedera itself is staking its treasury, and so is Swirlds Labs, and so is the HBAR Foundation, I think. I'm not sure about them, but I think a lot of big people are staking rewards. But Hedera, I know, is staking its rewards, and Swirlds Labs, and I'm staking, and I know a lot of people are staking. And you can, if you want, ask to not get rewards for your staking. So users have HBARs that they stake, and you mostly will be asking for rewards, and most people do. That's what you would naturally do. But I'm staking without rewards. Hedera is staking without rewards. We're just doing it to build the ecosystem and keep the ecosystem strong. We don't need to be rewarded for it. And so all of the coins right now are going to the other people, not us, who are staking. And I think that's a good way to do it. Make it optional whether you get the rewards. We turned it off. And so as you might imagine, the way it works is you pick a node that you trust and you stake your account to that node. If you want to stake to multiple nodes, have multiple accounts, and each one can go to a different node if you want. And then what happens is Hedera will be paying the node to be running as a node, if it's running. If it's not running, it won't get the node payment, but it'll get node payments. And then you will get a staking reward because you have helped to make the network safer. And so you get a staking reward because you are staking. This is what you might imagine we would do. We do have another thing too, though. If you want to, you can set this up where a person, like if you're the person on the far left there, You could set up a company, a gaming company, say, where you create accounts for all of your users. But they don't want to manage their account. They don't care about staking rewards. But what you do is, by default, you have all those accounts stake to your account indirectly. And then you stake to the node. And what happens is there is a reward, a staking reward for that stake from them. But the staking reward goes to you. And then if you wanted to, you could pass it on to your users. Or you could say, hey, you can play my game for free as long as you're staking to me. You could do that. Or you could just say, you could build wallet software and say, by default, it's going to stake to me. But when you get around to it, you could do your own staking and then it'll go to you. And so then you would, as the wallet developer, you'd be making money off of everyone who hasn't bothered to change it. But when someone does actually change it, then they get the rewards. And they would just change the stake to go directly to a node rather than to you. And then they get the rewards. So we only go one level of indirection here. If somebody stakes to them, it's ignored. It's only one level of indirection. You can stake to someone who is staking to a node, and then they get the reward, but the node is getting more weight in the consensus based on the stake. I don't know if I made that clear earlier. I said if it didn't get enough, it had no weight in the consensus, but also intermediate. If you have less stake, you get less weight in the consensus, less influence on what we're doing. And then finally, there's DREC. I am very excited about DREC. So DREC is the idea of decentralized recovery and custody. Decentralized custody is part of this too. We as an industry have a problem. It is too hard to use, and it is too dangerous in a way that is surprising. And really, it's the surprise that's the biggest problem. So think about the normal centralized world that we have today. You have your bank. If you lose your password to your bank, yeah, you can actually come to the bank and somehow get it recreated. You can always get back to your money even if you lost your password. You have your bank stock shares. Maybe you have a password to log into your stockbroker account. But if you lose that password, there's a way you can talk to your stockbroker. You can get your shares back. You have a passport. If you lose your passport, you can go to the government and you can get a new passport. The key to your house, if you lose that key, you can break a window and break in, if nothing else. Or you can hire a locksmith to come open the door. A key to your safe if you lose it, or if you lose the password to your combination to your safe, you can get someone to drill it out. If you lose the key to your car, there are people that will fix it for you, or you can break a window, or you can whatever, get a locksmith to help you. Anywhere in life that you have something of value, if you lose your key, if you lose your secret, if you lose your password, if you forget about it, there are ways to get it back. Ultimately, you can go to the court system and get it back. There are always ways of having a safety net. And everyone in the world right now that has grown up with a safety net subconsciously just assumes there is a safety net. However, we are building a future that is decentralized. And that means that right now there is no safety net. I have received emails from people who say, hey, I had a Hedera account and I had my 24 words and I lost them. Would you please generate another 24 words for me and send it to me so that I can get my money? I can't. It's not possible. I don't physically have the ability to do that. That's the whole point of a distributed ledger technology. The whole point of a blockchain or a DLT is that you can't take someone's money. And they can go to the court and say, hey, court, I really am me. Please give me the money in that account. And they can't get it. They cannot get the HBARs in their account or the tokens in their account, whatever. We don't have a safety net automatically in our industry. And this is dangerous because new people coming into the world of blockchain just assume there's a safety net. It's what they've grown up with their whole life. Every single thing of value in their life has a safety net. Just the idea that we wouldn't have a safety net never crosses their mind. We've got to fix that. And this is true for tokenized physical assets, so tokens, metaverse assets, online ID credentials, DIDs, and other things for identity, stablecoins, your voting power in a DAO. Not everything of value is money. Sometimes it's the right to vote in something, the control of something, power over something. All of those today, in our world, in our decentralized world, our blockchain world, our DLT world, in the Hedera ecosystem, all of that is ultimately governed by a secret key and maybe by a passphrase, a mnemonic that lets you recover that secret key. That's it. And so you can save it in a bank vault. You can try to give it to people you trust and hope they don't steal everything from you. But this is not a good solution. So what can you do? There's no FDIC insuring your account. There's no safety net. How can we build a safety net? So we've got to have the convenience of today's experience. This is the problem. I can tell everybody, go get a safe deposit box and put your mnemonics in the safe deposit box and etch them on metal first. You can do all of that. But it's so inconvenient, Grandma won't do it. Grandma might not even understand it. We also could go to custodial services. Okay, you can have an intermediary. But really, ultimately, we want to be able to give you security without an intermediary that you're trusting. We want to avoid centralization. But we got to have a safety net. We have to. Our industry will not grow to its potential until we make this easy and safe for everyone on the planet. So, why not do custody? Well, you should. I've told lots of my friends, use custody because, I trust custody more than I trust you. But the truth is, I don't trust custody either. I don't trust anybody. They could, if they wanted to, steal everything. Or they could be hacked and the hacker could steal everything. Or someone could pretend to be you and get your stuff from the custody. And you could say, oh, well, I'll have a key or a secret. Okay, but what happens when you lose your key or your secret? Probably the custody solution has a safety net for you. But maybe that safety net isn't very safe. How strongly are they going to KYC you after you lose your key or you lose your password? And then you could lose everything. So I don't like custody because it's centralized and has all the problems of centralized. You could do social recovery. That just means have an account that has multiple keys on it. So you store your HBARs and your tokens in an account that has multiple keys on it. And the keys are your helpers. And then if you ever want to pull anything out of it, a majority of them have to agree. Multiple problems with that, though I think it's better than the previous solution, better than custody. First of all, it shows the public keys of your helpers to the entire world. So it's not very privacy enhancing. Secondly, it's really a pain to add or remove helpers. You have to get the current helpers to manually sign a transaction that adds the new helper to your key. You have to change the keys on your account. That's a problem. And reliability also is a real problem. What happens if one of your helpers just loses the key that they would have on your account? They might not really care about it. And even if they care about you, if they're not using it every day, they wouldn't even know they lost it. Great. Well, you can recover if one of your helpers loses their key. What if all of them lose their key? You're dead. Or half of them, more than half of them lose their key. You're dead. You wouldn't even know it until you need it. And then you're out of luck. This is what's bad about social recovery. A better solution is decentralized recovery. So your actual account that the world can see only has one key on it. Okay, that's the key you created, just like today. Decentralized recovery is not just about a key on an account. It's about any kind of secret you have. It could be your password list, like you have in 1Password or whatever. Your password list could be done this way. The combo to your safe could be done this way. The keys on your account could be done this way. So it's for any secret you have. We want to do decentralized recovery. So what do? Well, again, you go out and find helpers. But instead of each of them having a key on the account, you take your key and you break it into pieces. Shamir secret sharing, you give it to your helpers. People have suggested this before. This is a good idea. In fact, if you think about it very carefully, it's clearly the only way we can do this. We have to do this. The only way to build a really good, decentralized safety net is to break up your key into pieces and give it to your helpers. And with Shamir, you can use any threshold you want, but remember, we're doing this to make it trivial for grandma and really hard for a non-tech savvy user to shoot themselves in the foot. We really want it to be hard to shoot yourself in the foot. So I think you would build in half the helpers have to help. If you want to recover, you need to go to half your helpers or more. That's what we would build in. We don't let grandma choose how many helpers because she's likely to choose, oh, I need all my helpers. And then one helper loses their key and she's out of luck. We say half your helpers. So we've dealt with the privacy. We have a safety net. Each of the helper gets an equal share. In this picture, it's a 1/4 share. You could have 100 helpers and have 100 shares. You can add and subtract helpers. When you use this app to add a new helper, it silently, behind the scenes, goes and talks to all the other helpers and says, oh, you used to have a 1/4 of the secret. Here's a new share. It's a 1/5 of the secret because I've added a new person. And so now everybody gets the 1/5. And if they are honest people, their program will erase the 1/4 that they used to have. And so they'll throw away the old share and just use the new share. By the way Shamir works is you cannot mix old shares with new shares. I can't get 1/4 of the people give me their old share and 1/4 of the people give me their new share and then recover anything. You have to have half of the people with the old shares or half of the people with the new shares. And if the honest people delete their old shares, it'll be really hard to get half of the old shares because most of them have disappeared. So this is important. And notice that I said it's invisibly, silently, automatically, behind the scenes, your phone is talking to their phones. This is critical. This is one of the standards that we're working on and that we will work with other ledgers and other organizations to submit to IETF or someone else to make it a real standard for how do we, behind the scenes, silently talk to people, because we really want this to work across different software. And we want to have a whole ecosystem, different ledgers, different software, even things like password managers that aren't even dealing with blockchains or DLTs. We want them to be involved. So that's the first thing we need, is a way to have a standard for how you split up your keys and give them to everybody. Then, the most important thing, bar none, if you remember only one thing from this entire webinar, is that your phone should silently, magically, behind the scenes, automatically talk to each of the other ones once a day. And just say, hey, do you still have that share that I gave you? And it comes back and says, yes, I still have your share, no problem. This is critical, because you may find that your helpers lose their phone, they get a new phone, and they don't even think about the fact that they've now lost your share. And if you don't check up frequently, slowly over time, those shares are going to disappear, and eventually more than half of them will have disappeared, and you're totally out of luck. You can never, ever recover. So you've got to have your phone once a day doing this. We built some demo software to show you how this works. We've gone through several versions of it, and we'll be doing that over this next year, showing the demo software. But this is the important part, is that silently behind the scenes, it is verifying your safety net is still there. Critically important. If it can't get a hold of Alice, then it should alert you, hey, Alice is missing. And if it alerts you for several days in a row and you don't go and get Alice to go recover her missing share, then it says, fine, I give up on Alice. And it automatically, behind the scenes, goes to everybody and says, you used to have a 1/5 share? Here's a new one. We're going back to 1/4 shares. Alice isn't part of our group anymore. And then you only need to have half of the remaining helpers help you. You don't have to have half of the bigger group that included the person that lost it. So we will do that. In addition to that, you could do helper as a service. Banks and lawyers could offer this as a service and say, hey, for a small fee or because you're our customer, we'll give you this free service. We will be one of your helpers. And if you ever need help, you can come to us. And so, and so this is how it works. And then, of course, I didn't say it, but if you ever lose your key, you lose your phone, you just get a new phone, you walk out to each of your helpers and you say, hey, can you help me? And they then connect to you and become your helper again. And as soon as you have connected to half of them, instantly you magically get your key back. It just happens. And it tells you who your other helpers are. The helpers don't know who each other are to keep privacy. But once you've reached half of them, if you've remembered half of them, then you'll get back all your secret. And one of your secrets is who all your helpers were. So you get to know who all your helpers are. So you will be able to recover your key. Everything I have said is decentralized recovery. I have a key. I can use it every day to be transferring tokens in and out of my account. But if I ever lose it, they can help me recover. Furthermore, you could do this as a sort of decentralized cold storage, decentralized custody. You could give up the key yourself. After you have a bunch of helpers, your phone could erase your key, and now you can't even spend your money without their help. And what you would do is when you want to transfer a token, you would send them all the transaction, and each of them would sign it. And when you get half the signatures, then the transaction takes effect. And the thing transfers. And so then you don't have access by yourself to your assets. That's what custody is. It is decentralized custody. It's incredibly important that we have this ability. So maybe you put a small amount of your funds in ordinary DREC and a large amount of your funds in an account that is just decentralized custody, that part of DREC. And this gives us then the safety net that we need. You can then be very confident in what you're doing. There's also lots of other details, like when they help you, you need to be in the room with them. And when they become your helper, you have to be in the room with them to prove that you are you. Or possibly when they help you later, you could do it with a video call, but you wouldn't set them up originally with a video call. There's lots of details to this. We'll talk about it more in other presentations, but it's important. The world is going to move to decentralized custody and decentralized recovery. No question about that. We have to have a safety net, otherwise the world will not use DLTs. Our industry just dies if we don't do this. We have to do this, and we will. And this is what we're going to be working this year. We're going to be working on those standards for how they talk to each other behind the scenes and submitting those as real standards with other organizations and other ledgers coming with us to jointly send them. We're going to release open source software, open source libraries, I should say, that will help you work. The whole goal is that this works with any ledger, with any secret, with any password manager. Someday, I hope it gets built into operating systems on computers and on phones, and it can have any kind of secret that you want. So this is the vision for DREC. Well, that's it. That is the state of the ecosystem, the state of our decentralization, the state of Hedera and the other organizations that we have broken up into. I appreciate the enormous amount that this ecosystem is doing and that you guys are doing. Thank you for all of your work on this, and I just look forward to building the future with you. Thank you.